Topic: Precision Farming Systems VRT, GIS. At the end of this lesson you should be able to understand the following concepts: VRT, GIS, remote sensing, soil maps, yield monitor, yield cards. Introduction. Learning content covered in grade 12 terms 2 and 3. Construction processes, tools and equipment. Concepts and skills. Precision farming/efficient mechanization. Globally, industries are turning to integrated digital products that promise increased productivity. This effective approach then leads to a larger turnover, something that every business strives for. The agricultural sector is no exception. Prosperous farmers use the best technological equipment for elevated borders at a lower cost. Precision farming is based on controlling input and data-driven decision-making so that farmers work smarter, not harder. Precision farming is especially used by young farmers because it is one of the many modern techniques used for effective production. There is no doubt that the pressure on the South African farmer is growing to work more effectively. With land reform, increases in input costs, changing weather patterns as well as the annual 2% growth of our country's population, this pressure will only increase. It is estimated that by the year 2035 South Africa will have a population of approximately 82 million people. The implication of this is that food production and imports will double just to feed the people of the country. This challenge is so real that the state has allocated us 6.2 billion to the Department of Agriculture, Forestry and Fisheries to help alleviate the impact of, especially the increase in wages, on the small farmer. However, it is not only the small farmer who is affected, but due to all the above factors, the commercial farmer is also hit hard in the mouth. Thus, mechanization must be viewed as a long-term solution for efficiency. Mechanization is good and well, but without control it will not be an effective solution. The smart way to get the most out of agricultural land with the least input costs is by investing in precision farming practices that function in synergy with the mechanical aspect. One of the most prominent precision farming systems for increased efficiency is satellite navigation. Using a navigation system, the farmer can not only cut his input costs, such as fuel and time, but also increase his yield by getting more plants per area as well as eliminating dead areas. The more accurate the GPS signal, the more effective the planting, fertilizing and harvesting process, leading to savings and soil optimization. Changing rate application in agriculture. VRT. Changing rate of application technology for better results. Variable rate application helps farmers increase their yields by using optimal fertilizers, seeds, and chemicals in the areas of the fields where the inputs will add the most value, while the inputs are reduced in places where it affects less yields. In precision agriculture, the application of variable rate is an invention that focuses on the automatic application of substances at a given location. The application of these substances is based on data collected by technologies such as sensors, GPS, and maps. These substances are inputs such as chemicals, fertilizers, and seeds. The main focus is on optimizing crop production. Changing pace application methods, application at varying doses focuses on different areas in farming activities, such as fertilizing, lime application, weed control, irrigation, and sowing. Some variable applications can be used using geographic positioning system, GPS, or even without GPS system. Two basic technologies for the application of variable application are map-based and sensor-based. Map-based variable rate technology (VRT) adjusts the appropriate rate based on a generated electronic card, also known as prescription card. The GPS receiver gives the field position and a prescription map at the desired rate. The applicator then applies the field position and prescription of a GPS as it moves on the land. For example, to develop a prescription map that will be used for nutrients VRT on a farm, the map-based method must have the following steps: perform systematic laboratory analysis and soil sampling for the field, Generate a site-specific map of the nutritional value characteristics of the soil. Then use an algorithm that will develop a site-specific map for nutrient prescriptions, and use the prescribed card to control an applicator with varying dose of fertilizer. Sensor-based application with variable application does not require any positioning system or map. Sensors mounted on the applicator simultaneously measure the soil properties or crop characteristics. The information is then streamed on a real-time basis. The control system calculates the amount of input required based on the crop or soil needs. Since both the sensor and map-based system have advantages and disadvantages, some manufacturers have made implements to take advantage of both methods. Other benefits. In general, variable rate application technology (VRT) is basically used to locate information about a certain field property and to have a system that can help make decisions based on that information. The decision taken will then determine what input to apply and at what rate. The critical benefit of applying at varying rates is that it helps in automating many agricultural processes while also preserving the environment. This further increases production and efficiency. The following are some of the additional benefits applicable to variable rate. 1. Savings on the use of fertilizers and other agricultural chemicals. 2. Potential increase in yields brought about by more efficient fertilization and spraying based on the actual harvesting needs and variability of farms. 3. Environmental protection and protection against excessive use of chemicals and fertilization or spraying of chemicals. Launched in the fall of 2013, the RG700 self-propelled sprayer is ideal for spray needs requiring a smaller tank size. The RG700 is Tier 4I compliant, and like larger Rogator models, it has an application-specific cabin design that maximizes driver comfort and the use of variable rate fertilizer spreaders (VRS) is available to farmers in many parts of Kentucky. For the use of VRS, a soil fertility map must be drawn up for the distribution of the field, which must be subdivided into the field. What are geographic information systems? GIS, Geographic Information System, GIS, is a computer system built to capture, look for, manipulate, analyze, manage and display all kinds of spatial or geographical data. In a simple way, GIS can be defined as an image that is signaled to the Earth with X and Y coordinates. Explanation of GIS. GIS in agriculture helps farmers to achieve increased production and reduce costs by enabling better management of land resources. The risk of marginalization and vulnerability of small and marginal farmers, who make up approximately 85% of farmers worldwide, is also reduced. Agricultural geographic information systems using geomatics technology enable farmers to anticipate current and future fluctuations in rainfall, temperature, crop output, etc. Map and project. Agricultural mapping is becoming more and more crucial day by day for the monitoring and management of land and irrigation of agricultural land. It facilitates agricultural development and rural development. Accurate mapping of geographical and geological features of agricultural land can help scientists and farmers to create more efficient farming techniques. As farmers are able to take more corrective steps in the form of better utilization of fertilizers, treatment of pest and weed infestations, protection of natural resources, etc., we get higher quality food production. A working GIS integrates these 5 key components: hardware, computer, software, data, people and methods. GIS, technology, advantages and disadvantages. Here are some benefits of using GIS technology. It has the ability to improve organizational integration. GIS will then integrate software, hardware and also data in order to capture, analyze, manage and thus display all types of information that is geographically referred to. GIS can also view, question, comprehend, visualize, and interpret the data in different ways to generate relationships, trends, and patterns in the form of globes, maps, and reports. Geographic information systems should help answer questions and solve problems by looking at the data in a way that can be shared easily and quickly. GIS technology can also be integrated into the framework of any enterprise information system. And there are many more jobs. On the other hand, there are also some disadvantages that you may experience due to the use of the GIS technology. And some of the disadvantages are the following. GIS technology can be considered as expensive software. It also requires enormous amount of data input required to be practical for some other tasks, and therefore all the more data to be entered. Since the Earth is round, there would be geographical errors that increase as you get on a larger scale. GIS can lead to costly errors once the real estate agents have to interpret the GIS card or the design of the engineer around the utility lines of the GIS. There may be errors in initiating efforts to fully implement the GIS. Remote sensing. Remote sensing is the process of detecting and monitoring the physical properties of an area by measuring the reflected and released radiation at a distance, typically from satellite or airplane. Special cameras collect images that can be seen remotely, which can help researchers observe things on Earth. Remote sensing can provide data that can identify and monitor crops. If this data is organized in a geographic information system, GIS, along with other parameters, it becomes an important tool for making decisions about crops and agricultural strategies. Applications to remote sensing in agriculture. Forecast of crop production. Remote sensing is used to predict the expected crop production and yield over a given area and to determine how much of the crop will be harvested under specific conditions. Assessment of crop damage and crop progress. In case of crop damage or crop progress, remote sensing technology can be used to penetrate the agricultural land and determine exactly how much of a given crop has been damaged. Analysis of horticulture, harvesting systems. Remote sensing technology has also played an important role in the analysis of different crop planting systems. This technology is mainly used in the horticultural industry where flower growth patterns can be analyzed and a prediction can be made from the analysis. Crop identification. Remote sensing has also played an important role in the identification of crops, especially in cases where the crop under observation is mysterious or shows some mysterious characteristics. The data of the crop are collected and taken to the laboratories where different aspects of the crop, including the crop culture, are studied. Estimation of crop hectares. Remote sensing also played a very important role in estimating the agricultural land on which a crop was planted. Evaluation of crop conditions and stress detection. Remote sensing technology plays an important role in assessing the health condition of each crop and the extent to which the crop has the resistance to stress. Identification of planting and harvest dates. Due to the predictive nature of remote sensing technology, farmers can now use remote sensing to observe a variety of factors, including weather patterns and soil types, to predict the planting and harvesting seasons of each crop. Modeling and estimation of crop yields. Using remote sensing, farmers and experts can also predict the expected crop yield of a given agricultural land by estimating the quality of the crop and the extent of the agricultural land. It is then used to determine the total expected yield of the crop. What is a yield monitor and yield charting? Yield monitoring and mapping. Yield monitoring equipment was introduced in the early 1990s and is increasingly regarded as a conventional practice in modern agriculture. The pioneers of precision agriculture have been compiling yield data for a number of years and have explored different ways of interpreting and processing this data. Yield mapping concept. Yield mapping refers to the process of collecting convincing data on crop yields and characteristics, such as moisture content, while harvesting the crop. Various methods are used to use a variety of sensors to map crop yields. The basic components of a grain yield chart system include grain flow sensor, determine the grain volume harvested. Grain view sensor, compensates for the grain moisture variability. Grain elevator speed sensor, used by some mapping systems to improve the accuracy of the grain flow. Measurements. GPS antenna, receive satellite signal. Yield monitor screen with GPS receiver, transfer and collect data. Sensor for head of land, distinguish the measurements recorded during turns. Travel speed sensor determines the distance the harvester travels during a certain log interval. Sometimes the speed is measured with a GPS receiver or a radar or ultrasonic sensor. Each sensor must be properly calibrated according to the user manual. Calibration converts the signal from the sensor to physical parameters. During harvest, a separate binary log file is created to record the output of all sensors as a function of time. This file can be converted to a text format or displayed as a map using the yield monitor provider software. Processing of yield cards. The return calculated on each field location can be displayed on a map using a geographic information system. GIS software package. A return monitor.
Please like, share, and subscribe to the channel for more future educational videos.